Okay, so as I was saying, there's a couple different ways that you can find the maximum or minimum value of a parabola, so we're going to refresh those. Again, this is all grade 10 review. Nothing about this is new. You have done this all. So there's some kind of like comfort in that there's no new content. So if we're in standard form, which is like this f at x equals ax squared plus bx plus c, we know that if a is greater than 0 or positive, right, if you want to say positive, then it's opening upward. And there is a minimum value. Right, so it'll look like that. So they'll be at the bottom of the parabola. There's going to be a minimum. Versus if a is less than 0 or like a negative number, like negative 2, negative 5, then it opens downward and it's going to have a maximum value. Right? And our parabola is going to be this frowny face with a super max point, the highest point on the grid, something like that. Right, so that's how you can tell off the bat just by looking at an equation what's kind of like the shape of my parabola. What's it going to have? Fair? And then there's 3 different ways. So we're going to practice all 3 different ways today. So one is like a cheat code. It's like a quick little formula that can tell you the x value of the vertex just from standard form. And then you could plug that into your equation to find a y value. So there's that one. Second is using the zeros, so going into factored form and then using those to find your axis of symmetry and then finding your vertex there. Or, not really a fan favorite, completing the square. Not a lot of people like completing the square, but we're going to practice it because it is fast. So for method 1, our quick little like hack to finding it, we are going to use x equals negative b over 2a. And that's going to tell us our axis of symmetry, which is like the x value of your vertex. So in this case, if I've got 2x squared plus 4x plus 1, my a, Ryan, are you so eager? Right, what's my a? 2. My b is 4, right? If this is your a, this is your b, and this is your c. So then if I'm just going to use that equation, then we said x equals negative b over 2a. I'm just plopping those values into that expression. So negative 4 all over 2 times 2. What's that's going to simplify to? Right? 2 times 2 is 4. And then negative 4 divided by 4? Negative 1. Voila, right? This is my x value of the vertex. If I want to find my y value of the vertex, I'm just going to now plug in negative 1 into my equation because I know that is the x value that the vertex is happening at. So f at negative 1 is equal to, 2 times negative 1 squared plus 4 times negative 1 plus 1. Which I believe this is going to give us 2 minus 4 plus 1. So I think this is negative 1 altogether, because 2 minus 4, negative 2, and then plus 1, negative 1. So therefore, our vertex is negative 1, negative 1. Right, so quick formula using a and b, and then just plug whatever value you find into your equation, and that's your y value, and that's the vertex. How do we feel about that? Yeah? If you feel comfortable enough, try the second one, right? Identify what's your A, what's your B, and then use the formula, negative B over 2A, and then just plug whatever value you find for that into your function. So try it. Turn to the people around you, see if you can do it. And then let me know what you get. solve it. Oh, well, you're plugging it in. Perfect. So then, yeah, it would be negative. So it becomes negative 4. Because it's negative 1 times 2 squared. We got the negative in front of it. So it's like saying negative 1 times 2 squared. Yeah. You get the same thing? Let's see. Should we do it together? Yeah. Okay, let's do it together. So, step 1, I gotta identify what's my A, what's my B, which in this case, my A is negative 1 and my B is 4, right? See the negative sign here? That is attached to A. That's a negative 1. So, okay, if I'm gonna do now my formula, negative B over 2A, this is going to be negative 4 all over 2 times negative 1, which this gives me negative 4 all over negative 2, which is just going to give me positive 2. So that's my x value of the vertex. Whoa, that was an ugly bracket. X value of vertex. And then step 2 is now I'm going to take that value and I'm going to plug it into my expression, which f at 2 is going to be equal to, notice, negative 2 squared. So the negative does not join the x, like on the inside, right? It's like you're saying negative 1 times 2 squared. And then I continue. Plus 4 times 2, plus 3. And I believe this gives us 7 to finish with, because this is going to be minus 4 plus 8 plus 3, which is 7. So therefore, our vertex is 2, 7. Quick, easy, right? Not bad. And it's not that bad of a formula to memorize. So that is one way you can do it. We're good to flip to the next page? Am I good over in this table? Abby McKenna, I'm good to flip? We're good? Okay, cool. The second one is if you're in factored form. So then you could FOIL, select like terms, and then do the whole x equals negative b over 2a. Or you can use your zeros of the equation to determine your axis of symmetry, which is your x value of the vertex, and then find the y value. So same thing. So okay, step 1, I gotta factor her. How can I do that? Product 5, sum negative 6. What are my two numbers gonna be? Negative 1 and negative 5. I think that works, because negative 1 times negative 5, positive 5. Negative 1 plus negative 5, negative 6. Okay. So now my brackets are going to be x minus 1, x minus 5. And then your two zeros are happening when y is equal to 0. Right, so if I set my function equal to 0, that's why I'm saying y is equal to 0, which is the x-axis. So one option is going to be this bracket, x minus 1 equals 0, or x equals 1, and same thing, x minus 5 equals 0, or x equals 5. Those are your two x-intercepts. It is crossing the x-axis at 2 points. Is this step okay? So all I did was product and sum factor. I set it equal to 0, and then I just said each bracket equals 0, and isolated x. So you can notice, like, it just flips sign.
You know, just like write the restrictions and just see those.
Well, restrictions is what it can't be.
But isn't it
Hmm?
restrictions are the same?
The like on the domain?
Like,
This is, we're saying what x can be, not what x can't be.
it's like x and
It can't be?
yeah.
Why not?
Wait, I'm confused.
Restrictions are for like a rational function, like what we did before, because there was a denominator and we said the denominator can't be 0, right? But in this case, we don't have any restrictions on a parabola, like on its domain. X can be anything. XER is the domain, right? So it's not. But it's like in the idea of like you were solving for restrictions, that's what you can do, right? But X can be those values. Step 2 is now I have to solve for AOS, which, AOS, if you don't remember, is just the average of your two x-intercepts. So you're just adding them together and dividing by 2. Alright, and we're just going to say x equals, right, because this is the x value of the vertex, 1 plus 5 over 2, which really is just 6 over 2. And 6 divided by 2 is 3. Do we kind of remember some of these formulas coming back? Yeah? Way back when? How many of you last did math in January? Like semester 1. Okay, so it's been a minute. A lot of you. Okay. Right, so it's coming back. It'll take some refreshing, but it's fine. So x equals 3. This is the x value of the vertex. Right, that's what our axis of symmetry is. That line that cuts our parabola directly in half, it's going through the vertex. So then step 3 is let's plug in 3 into our function. Right? You could plug it into the factored version if you like, or just plug it into the original. Either way, you will get the same answer. So it doesn't matter which one you do. But I'll just do the original to stay like consistent. Right, so f of 3. This is going to give me, oh gosh, 9 minus 18 plus 5. Well, 9 minus 18 is negative 9 plus 5. So that should give me negative 4. So therefore, my vertex is 3, negative 4. All right? Okay. Does someone want to try the second one on the iPad? Have some iPad time? No? You? Yeah? Oh my god, that makes me so happy. Yes! Give it up for Kian! Yes, Kian. Okay. And you'll have to walk the people through what you're doing.
What?
Right? Pretend like this is your lesson. You're teaching them.
How?
Well, you're just talking out loud. I'll be right here.
Okay.
Okay, so step 1, we got to factor and we got to state the x-intercepts.
So the product and sum of.
Yeah, and you can touch it. It has
I
palm
can.
projection.
Okay.
Yeah, and you can zoom in if you like. Oh, you're in eraser mode. There you go. Okay, so we're doing product and sum.
So the product and sum, it needs to add up to negative 2
Yeah.
multiplied to negative 3.
Yeah,
So it would be negative 3 and positive 1.
I think so.
Yeah.
So 3 and negative 1, because 3 times negative 1, negative 3.
Yeah.
3 or negative 3 times 1, I think.
Yeah.
Yeah.
And then so it'd be
So we said x minus 3 and then x plus 1, solid. And then what are my two x-intercepts then?
it would be x1 plus x2 all divided by 2.
But even in step 1, what are my two x-intercepts?
Oh, x equals 3 and x equals negative 1.
You got it, so let's state those.
And then
And now we got to average them to find our AOS. So 3 plus negative 1. Which we're going to change a little sign there. Perfect. Or 3 minus 1. Either way, 3 plus negative 1 and 3 minus 1 are the same. So that gives me 2 over 2.
yeah, so just 2.
2 over 2. You got it. Okay, so 1 is our x value of the vertex.
And
Right? Because
then-
we did 3 plus negative 1, which makes 2. And then 2 divided by 2 is 1. Okay, and then last step, we've got the x value, we've got to find the y value.
So we sub in 1 for x.
Exactly.
Or,
We can do f at 1, yeah. Perfect.
and then I'll use the original equation.
Sure, you can use the original or factors, whatever floats your boat. So 1 squared minus 2 times 1 minus 3, which, okay, 1 squared is just 1. And then 2 2, negative 2 times 1, minus 2, and then minus 3. So 1 minus 2 minus 3. You got it. So vertex is?
1, negative 4.
You got it. 1, negative 4 is our vertex. Cool.
Yeah.
Yeah, you got it. Mm-hmm. Thank you, Kian. Yeah, go ahead. Mm-hmm. That's going to be a decimal or a fraction. So Ryan's like, okay, the next one, yeah? Yeah? Okay, hold on, peeps.
You did the opposite. I did minus 3 at the top.
But then it would be negative 1 plus 3. Because this is negative 1, x equals negative 1, and this one's x equals 3. So then if you flip them, it'd be negative 1 plus 3, which would still give you 2 over 2.
Go to the library now.
Oh, good luck.
I just don't understand.
So this one, because we set the bracket equal to 0, see how we did it up here on this one? On this one, I don't know if you want to look.
Yeah.
So then this would be x plus 1 equals 0 or x equals negative 1. Alright, that's the bit. So Ryan says this is going to be ugly and sussy for this one. So same thing, product. I've got 2 times negative 6, so negative 12. And then my sum is negative 1. Which if I'm thinking about 2 numbers, what did you get, Ryan? What were your 2 numbers?
Minus 4 and plus 3.
Minus 4 and plus 3. And then the ratio method that I've now learned and I'm obsessed with, we take a to our first integer and then a to our second integer, which this can simplify to 1 to negative 2. So we've got f at x equals, we've got x minus 2, and then we've got 2x plus 3. Mm-hmm. I loved it. I love the ratio method now. You could also do factor by grouping, like old school, but it does seem like the ratio method is superior. So now if I set this equal to 0, right, my first one is going to be, okay, 0 is equal to x minus 2 or 2 is equal to x. So same idea like with the restrictions, like how you're flipping the sign. Same idea. And now this one, 2x plus 3 equals 0 or 2x equals negative 3 if I'm bringing 3 over. And then if I divide by 2, I get negative 3 over 2. Or about like negative 1.5. Right, so those are my 2 x-intercepts. And then same thing, it doesn't matter that I have a fraction, right? So my AOS is going to be equal to, I'll do x1 plus x2 all over 2. So this is going to be 2 plus negative 1.5. Which is just going to leave me with 0.5 on top. And 0.5 divided by 2, what is that? 1 over 2 divided by 2? Is that 1/4? Because 1 over 2 divided by 2 becomes 1 over 2 times 1 over 2, so 1 over 4. So 0.25? Yeah? Fact checked? Cool. So then step 3, would be plugging in 1 over 4. So then f at 0.25, 2 times 0.25 squared. Oh gosh, I'm not going to be able to fit. Minus 0.25 minus 6. Which, what does that leave us with? Somebody, calculator. Who's on calculator Dewey?
What does that do?
This is me plugging in 0.25 into my original function. So 2 times 0.25 squared minus 0.25 minus 6. What do I get?
I just did it with fractions.
Okay, what is it as a fraction?
So the 2 and then the 1/4 square root end up as 1 over 8. Once you times it by 2, it was
Okay.
1/16. So whatever that is in the decimal.
So
and then
1/16.
times it by 2, which is 1
1/8.
over 8. 1/8. Yeah, so 0.125.
0.125.
And then that would also be minus 0.25, or and then minus 6, and my final answer was negative 6.125.
Negative 6.125. Perfect. So your vertex might not always be pretty numbers. Right? Like this is an ugly decimal point, but you can still use the same method. It does not change. Don't be alarmed by the decimals.
Miss Amber,
Yes.
use the other method.
Hmm?
Just don't do the ratio.
But this, because there's a value in front, we can't just pop them into brackets like this. Because then if I go to FOIL, x times x is only x squared, not 2x squared. So we gotta do the factor by grouping or the ratio method to make them in those brackets. We can work on this, like in the work period. Okay, am I okay to move on from this onto our last and final method? Yes? I'm okay to go forward? We don't have any questions about this? Okay, or at least for now. Ooh, my screen recording ended. Okay, so last but not least is completing the square. This is if you want to go from standard form, so like ax squared plus bx plus c, to vertex form, which is, for your reminder, a and then x minus h squared plus k, this whole thing, if you remember it, where h and k is your vertex. So like it tells you what the vertex is in the equation. So there's a couple steps for completing the square, and there's two different options. When a is 1, so it's just x squared, or when a is not 1. Then there's a little extra step, right? Yep. No, we can't miss completing the square. Whether or not you choose to do it, you could try avoiding it your whole life, like in math, like in your math career, you could try avoiding it, but it will haunt you. It'll come back for you. You could try the other two. But okay, step 1, we're gonna do a when a is 1 first, so just x squared. Step 1, I'm gonna place the first two terms in their own exclusive brackets. That's it. So I'm just putting the first two terms in their own brackets. Step 2, I need to make now this bracket a perfect square trinomial. That's the goal. How do I make it a perfect square trinomial? I need to find the magic number, which the magic number is just going to be b over 2 squared. That is your magic number. That's how you find it. So my b value is 8, so we're going to do 8 over 2 squared, which 8 over 2 is just 4. And like Ali said, 4 squared is 16. That is my magic number. Yay. Now, step 3, we're going to put a positive and minus version of this magic number into our brackets. So now it's going to look like f at x equals x squared plus 8x plus 16 minus 16 plus 1. Maybe this is going to come back to you. The negative one, we always give it the boot. We kick it out of the brackets. We do not want it staying with the other terms. We want it to all be positive. So we are going to kick it to the outside. So f at x is now equal to x squared plus 8x plus 16. And now on the outside of the brackets, we've got our plus 1 minus 16. So I got the boot.
Plus 16.
Does not change sign.
Oh, 'cause it's not going from side to side.
Yeah, it's not we only change signs if it's on like moving to another side of an equal sign.
Yeah.
But we got no equal sign here, so it stays the same sign. So it's still minus 16. Now, we can simplify on the outside, 1 minus 16. And this is a perfect square trinomial now. If you were to do product and sum, you would come across two numbers that are a pair. So like 2 and 2, 5 and 5, -4, -4. Or it will always be whatever b over 2 was. B over 2 is 4. So we know that this is going to be x plus 4 squared, and then 1 minus 16 is -15. So our vertex is at -4, -15. Right, so it's very tedious. Put in brackets, find your magic number, plus minus version of magic number, give the negative version the boot, and then simplify. Right, and we know that this plus, where's my finger? There we go. This is actually minus, right? It means you're shifting to the left into the negative. So remember to switch this sign. Our vertex is not 4 negative 15, it's negative 4, negative 15. Right? We're going to take the training wheels off, and I want you to try the next one. Follow the same steps. It's those same 6 steps. It's really only 5, because I just said step 6, voila. So try those 5 steps. Place the first 2 terms in brackets, find your magic number, plus minus version of the magic number, kick out the negative, and simplify. All right, try those. Yeah. Yeah. Hi, friends. Hi, friends. Okay, so I just want to go back and like finish off what we did yesterday. And so for the people who missed yesterday for the English field trip, I think I got that right. We did how to determine maximum and minimum values of a quadratic function. So we did these 3 methods. X equals negative b over 2a is one way to find the x value of the vertex, and then you just plug it in to solve for y, using the zeros to find the AOS, and then solving for y, or completing the square. So we practiced those things yesterday. And the last thing that was left that we didn't get to because the iPad died was word problems. So where are you going to need to find the vertex in a real life application situation? So some people started these, but I'd still like to take them up in case people were confused. So it says a golfer attempts to hit a golf ball over a gorge from a platform above the ground. The function that models the height of the ball is this h of t equals negative 5t squared plus 40t plus 100, where h of t is the height and then t is the time in seconds. And it says there are power lines 185 meters above the ground. Using this function, we need to figure out whether or not the ball is going to hit the power lines. Right? So I need to figure out, like, what is the maximum height of this ball? What's the max height? And is it going to be 185? Is it going to be under 185? Over 185? We need to figure that out. So, okay, step 1, I need to figure out what I want to do. What's my method? What method did we like the best from yesterday? Because you could use all 3. You like the first one? Okay, Esther's saying the first one. Let's use the first one. So we're going to say x is equal to negative b over 2a. What's my b value? So negative 40 all over 2 times my a value. So it just gives me negative 40 all over negative 10, just 4. So therefore, max height is occurring at 4 seconds. That's like the time when the golf ball hits its maximum height. Occurs at 4 seconds. Part 2 is then, okay, well, I need to find like what is the maximum height. So I'm just going to plug 4 into my equation. So h of 4 is equal to negative 5 times 4 squared plus 40 times 4, and then plus 100. Which, well, bed mass, negative 5 times 4 squared, so 16. Did you get this one, Beta? What was it? Was it 180? It was 180 exactly. Positive. Negative would be like in the ground. Yeah, I'm doing the entire thing. So we know if the maximum height is 180, is it going to hit the power lines? No, it's going to be right under the power line. So we'll say the max height of the golf ball is 180 meters. So it will not hit the power lines. I could have also completed the square if I loved completing the square. I could have also put this in factored form and then found the AOS. I still would have got the same answer. Yep.
Can you actually do completing the square?
For the next one, I don't know if it would be the best method. It might get a little more complicated. I'm going to do completing the square with you. Because with demand functions and business functions, so if you're thinking commerce, this is kind of the math that's like going to be applicable to you, where you're talking about demand functions and profit functions and revenue functions, right? So this one's talking about a magazine. The demand function for a magazine is P at X, where this is just a line, minus 6X plus 40. And that is the selling price in thousands of dollars of the magazine, and X is the number of magazines sold. And it's saying this is the cost function, what it costs to make the magazine, which is another line, 4X plus 48. And it's saying calculate the maximum profit of the magazine and the number of magazines that you would have to sell to hit that maximum profit. So we can't just go into like completing the square. We have to do some manipulation first. And that's why I put reminder. Revenue is equal to demand times number of items sold. So my revenue function is going to be equal to the demand function, P at X, times number of magazines sold. X is the number of magazines sold. So I just have to times the profit function by X, which you're going to see, the demand function by X, which is going to be negative 6X plus 40 times X, which simplified just gives me negative 6X squared plus 40X. All right, so that's step one. Step two is then the profit function is your revenue function, which we just found, minus your cost, right? So profit, which I'll do capital P instead of lowercase p, is equal to R of X, now minus your cost function. So now this guy that we just found, negative 6X squared plus 40X, minus this one here, our cost function, 4X plus 48, which then that's just going to simplify to negative 6X squared. And then I've got 40 minus 4, so 36. And then just minus 48. Voila. Now that we have this profit function, that's the one you're going to factor and find the vertex of. So you could complete the square. We've got some big numbers, though. Completing the square might get a little yucky.
Yeah, but you can factor out.
Would we like to do completing the square for this one?
I just
You want to
want to
practice?
You guys don't even have to do it. You just look at it, just watch it.
It doesn't hurt to practice. I think we should practice. You could use, if you want to independently do it on the handout, you could use the other two methods if that's what you prefer. I'm never going to say specifically do it completing the square or do it this method. I'm just going to ask you to find the vertex. All right? So, okay, if we're going to do that, step one of completing the square is I need to put my first two terms in their own separate brackets. So I got minus 48, flashback. And then we said we need to factor out a GCF just for the coefficients, not touching the x's, right? So just negative 6. They're both divisible by. So I've got x squared minus 6x and then minus 48. We leave the x's behind because our goal is to make that bracket a perfect square trinomial. So if we take out x's, then it's not going to be a trinomial anymore, right? So that's the goal. What happens now? Do we remember?
You add 9 in the bracket.
Well, where did 9 come from? You have to say it. What is it?
You have 6, you square it, which is 9, and then you add it into the bracket, and then after that you're going to subtract, or you're going to do negative 6 times negative 9, whatever that is, which
Yeah.
is positive plus 48 outside of the bracket.
People who were here yesterday, what did we call this? The
Magic number or something?
The magic number. So what Lucas is talking about is that we need to find the magic number. So magic number. What number or what constant in this is going to make this a perfect square trinomial? Which we said it's just b over 2 squared. Right? So this is negative 6. I take the sign with it. 2 squared. So negative 3 squared, which is 9. Hence why he was saying, oh, I'm just going to input 9. All right, so we're going to then do the plus and minus version of 9. Someone asked me yesterday, do I have to do it? Can I just kick it out right away? Sure, if you know, but I just like to do as many steps as I can to like make it simplified. Ooh, and then plus minus 48. With the negative, what did we do to the negative? We gave it the boot. And when I pull it out, I still have to times it by this a value that's in front. So this is going to be minus 9 times negative 6, right? Because the negative 6 was in front of the bracket. So everything in here, it's like you're assuming it's getting multiplied by negative 6. So then last step is, okay, my brackets are now a perfect square trinomial. I'll keep it like this. We said minus 6x plus 9. And then that's going to be minus 48. And then, oh gosh, plus 56. Did I get that right? 54. I was so close. Yes. Your glasses?
Which is 6.
So I have plus 6 left. Okay, now this is a perfect square trinomial. You could do product and sum and be like product 9, sum negative 3. Or it will always be whatever b over 2 was. So if I look, I'm like, oh, b over 2? B over 2 was negative 3. So I know this is just going to be x minus 3 squared plus 6.
That's it.
So then what's my vertex of this equations? 3, 6. Does that mean I'm selling 3 magazines and I'm making $6?
No, because it's in thousands.
So the units of the equation, right? In thousands of dollars, right? That is where it represents that. And X is the number of magazines sold in thousands, right? So pay attention to the units. So therefore, 3,000 magazines make a profit of, if that's still thousands, not hundreds of thousands, so $6,000, that sucks. It's a bad company. They're selling them for like next to nothing. Maybe it's a startup. I won't judge. But that's it. So that's what your vertex means. So when you go to actually say the answer, right, make sure it's in the proper units, right? It's not 3 magazines and $6. It's 3,000 magazines and they make $6,000. How do we feel about these word problems? And completing the square. I know we don't like completing the square. I don't like completing the square either. It's just one of those things, right? So again, with these questions, it's up to you how you want to interpret it and how you want to solve it. You could have used any of the 3 methods. You can see this one gets a little lengthy, a little messy, especially when you have coefficients this big, right? So it's up to you how you want to proceed, right? So we'll practice these. And so for people who were missing yesterday, there was some practice.